Oh, welcome to a new video. This is Mo and I'm glad to be the presenter today. This video is about a lecture that I've given at the University of Greenwich about the new ways of working for quantity surveyors. And this lecture, it included 5 main sections or chapters related to a wide variety of things, taking into account the classical or the traditional skills for quantity surveyors, what we were doing and how to take it up a notch to the next step, in addition to the new emerging technologies, the digital mindset, and how we can bring it all together. I would like to apologize about the quality of the voice in some of them parts of that lecture, and that's because I was recording from my laptop and sometimes I was away from the laptop explaining some bits and pieces on the whiteboard. I've tried to do my utter best to tackle this problem by doing voice isolation, noise isolation, and also providing subtitles and taking out any irrelevant voice sections from the lecture video. And now I'll leave you with the lecture. Afternoon all, this is Mo, you can call me Mo. I'm going to try as much as I possibly could not to bore you to death, so let's fire away. So just a bit myself, I'm a civil engineer by practice, did my quantity surveying with Professor Sylvester 8 years ago, and then I started working with the classic consultancies that the vast majority of you all are going to be working in, like Watt McDonald, Atkins, all of the big names. And then 5-6 years ago, I started to dip my toes in data analytics, because working as a QS is so boring when you're doing the valuations month in, month out. And I'm a little bit of a geek myself, like Professor Sylvester, but when it comes to the professional bodies, I've got a couple of consultorships under my belt. And yeah, I've worked with contractors, clients, and consultants. And now I'm working in something called cost intelligence, which is a very fancy name for quantity surveying. So let's start. The lecture today is going to be composed of 5 main sections. I prefer to call them 5 acts because I want all of you to be with me in this journey. So we're going to be starting just a little bit, mere repetition of what Sylvester has already spoken with you about over the last X semesters. And then we're going to be speaking about what do we mean by intelligence? What do we mean by cost intel, time intel, risk intelligence? And then we're going to be speaking about the hype that you all see nowadays, the LLMs, AI. We're going to be speaking about the skills that all of you folks have to, I'm not going to say have, it's nice to have, especially that you're going to graduate sometime soon, and all of them companies nowadays are looking for digital-minded professionals in different fields. And then we're going to be ending it on a very good note. I'll try as much as I possibly could not to be boring in this lecture. So, starting with the classic stuff. So, you have all studied the classic quantity surveying, procurement routes, contracts, NEC, JTC, all of that stuff, manual takeoff, methods of measurement, and all that. So, you will find that we're all have been doing this for hundreds of years now, because the RITS, for you to know, has been established since 1868, should I say, by John Clausen. So, that's more than 160 years ago. And where we are at the time being, quite a lot of professionals that use the digital tools like Power BI. You will all listen to and hear this kind of flashy names for digital tools that are used in the construction industry. And the hype, AI, okay, so what is being done at the time being? How can we use these LLMs to perform predictive analytics, and how can we make the best use of them actually in our work beyond the hype? So, as we have alluded to, traditional skills, all about the methods of measurement, how you can undertake a quantity takeoff, review the contracts, understand different clauses and where the gaps are. And the traditional tools have always been like Costex. I'm not sure if you have heard about it or not. Costex is used for taking off or creating a bill of quantity, creating a cost plan. Definitely Microsoft Excel. I'm pretty certain you have all used Microsoft Excel in different bits and bobs. PDFs or drawings, specifications, bills of quantities. And I should say, finger in the air approach for QSs about how to price stuff, how much the concrete costs. No one knows. It's a finger in the air approach. I'm not going to say strict, but it's sort of people like potentially your granddad's age or my dad's age. They think they're doing it well, they're smashing it. So I beg to differ. Sometimes it's brilliant, sometimes it's not as great. And the main challenge is how can we deploy the latest science, the latest advancements in order to provide value for money for different clients, for different contractors, and definitely for different consultants. So the digital disruption, where we're heading, we're receiving a huge influx of data. I'm pretty certain I've heard about the BIM models, 4D models, 5D models, 6D models, even 7D models. So all of these models represent a substantial amount of information storage space on your PCs or on the cloud. We do possess some technologies that are site diaries. So basically, when you go on site, what is happening on site? Who has entered the site? Who has exited the site? So there are some cloud-based knowledges which record that. Definitely have studied drones. So we do have a substantial amount of drone footage for different sites, which is then ingested to build a 3D point cloud. And you can make this use of, I'm pretty certain I've heard about GPT and Claude and all of these models, and you can use an API or an application programming interface to link to these models, which means a huge influx of data. In the industry pressure itself, all the C-suite, they are pressuring us to provide value for money. They are looking at specific metrics that they need us as professionals, whether you're a PM, QS, risk manager, a designer, to target. One of the things, and I think that is going to be quite relatable to you folks, is that we are suffering from a huge skill gap, and that is problematic because the RICS, they said, guess what? Over the next 10 years, 25% of QS is going to retire. So that gives you a huge room for improvement, and we need that skill. Even myself, I'm not that old. I am seeing it in the new graduates. There's a huge skill gap between us and themselves. And that's going to give you, I hope after this lecture, it's going to give you some insights about where you can build on yourselves in terms of skill sets so that you can smash it when you join the workforce. If you could please join minty.com and use that code that you can see on the screen. Oh, very interesting results. I'll be quite interested to know where exactly or in which cases exactly do you use it. I have never used it, but I understand because the majority of the subjects are unfortunately not that enticing to use coding or programming in. How many of you folks have heard about data visualization tools in general, with a Power BI, Tableau, QLIC, all of them ones, not necessarily Power BI. It's very good that a percentage of you have heard about it. Which LLMs do you use? Which AI tools do you use for your studies? Write in that paragraph, Gemini, ChatGPT. Okay. Did you have the chance, any of you, to work on large data sets? Let's say thousands of rows of data of anything at all. Costs, time, anything. In Excel or in any piece of software, it doesn't really matter. Nature of the large data sets that you're using or you're getting exposed to. So let's jump back to the presentation. So we have now finished the first part, which was the overview. So the intelligence, you would, once you finish this course or your degree, you will hear all about the intelligence, risk intelligence, time intelligence, cost intelligence, mainly cost, time, risk. From my own perspective, that's based on what the clients really want. Cost intelligence is all about understanding what changed month to month, any trends, inflation, having sort of like a unified resources unit rates database. At the time, if you're working as a planner, you would be expected to compare and contrast what is happening between the baseline and any P6 submission month on month and the likes, and understanding how much or what is the productivity of different labor and plant in different activities across a lengthy time frame. And then for the risks, well, the risk at the time being is sort of qualitative risk assessment. So you would really need to put numbers in so that you have an educated decision or quantification of the risks. And I'm going to be expanding on each and every single one of them, don't worry. So the classic stuff for the cost intel, you would, or myself and Sylvester, we did it back in the days in uni. The professor provided us with a very small assignment, quantify this foundation from these drawings. You have a PDF, you have a foundation, and a couple of them ground beams, some concrete, some rebar. Do a quantification of these works. And the classic approach is that you search online or you search in price books for the rates, and then you measure the quantities, you multiply by the rates, you have the costs. But the main problem with this approach is that which rate are you going to pick up? There's always going to be a spectrum. There's always going to be a range of the rates from a lower bound to an upper bound. And there's going to be definitely an average. So which rate you should pick up? The concrete could be anywhere from 180 quid per meters cubed to, God knows, 350. Traditional approaches, unfortunately, they rely on point estimates. The cost intelligence is sort of, you try to provide a wider range of data for different people. They can have a wider spectrum of scenarios for the pricing itself. Clients nowadays, because of the hype of AI, it's all about predictive analytics, predictive modeling. How much this is going to cost me in the future. So you're trying to use machine learning models to train on previous historical data, and then you try to target a specific date in the future, and based on all the data that you have, based on understanding the parameters of these different projects, you can then extrapolate in the future. So think about regression analysis if you have studied it. Another thing, I'm not sure if you have heard about it or not, Karelian, one of them contractors, they went bust some time ago. That is the real-time market intelligence. People, any one of us, could listen to the gossip in the industry, go to conferences, listen to what's happening. That is the real-time market intelligence. So listen to the gossip, understand the different prices of different materials in the market, from what's called Perkins to Lawson's, to the different suppliers, and definitely with regards to the plants as well. The anomaly detection, what it entails is that if you have, for example, a project like HS2, okay, it's super expensive. If you compared it to any high-speed rail in Europe, it's going to be super expensive. That is going to be always an anomaly, an outlier. You cannot compare it to other projects and say they must cost the same or around it. The analytical techniques, without digging, because that is not a mathematics course, I'm gonna fly through this slide and then show you the graphics in the next slide. So regression analysis is basically, you have a lot of data in the past and then you're trying to understand how much something is going to cost you in the future. You're going to have a lot of data points on a scatter plot, and then you're trying to draw an imaginary line to enable you to understand how much in the future something is going to cost. The clustering and segmentation, that is an interesting one. That can be quite useful in benchmarking, not prediction. You can have a scatter plot, lots of data points, and then you're trying to draw some sort of like a polygon around the data points that have similar behavior. The time series analysis, yeah, we're approaching Christmas, so you're going to have quite a lot of Christmas trees that are being bought in a month from now. So the time series analysis relies on understanding the behaviors of something over time. For example, you can have a lot of Halloween related treats, pumpkin fruit being sold massively during October. The same with Christmas trees. So you would expect that in December, a huge amount of stuff are being sold in that specific category. And the same can happen in construction as well. So let me show you the images so that it can be easier for you. So the regression is basically, you're going to have here, for example, the quantity of the product. Let's say gross container floor area. And here you have the costs in pounds, or whichever currency matters. And then you have all the areas of the project, or the price per meter square, which you can easily, using machine learning or whichever, in Excel, there's something called trend line. Then you can draw that line, give you the equation, and then you can use that equation to predict sort of some of the projects. The time series analysis, understanding the behavior is called seasonality. Seasonality is how frequent a specific behavior repeats. So seasonality, for example, of Christmas tree being sold in December. Seasonality happens in December. It's the same for Halloween. This is more in the sales, but sometimes it happens in construction. Sometimes in specific months, you're going to have to stop working because it will happen. Take, for example, here in the UK, February, lots of storms, hurricanes, tornadoes, and the likes. So this means that there's going to be always a seasonality in February concerning the low productivity of the works. The clustering here, that is quite interesting for benchmarking. We are trying to compare and contrast the costs of projects, so that you could advise with some degree how much projects could cost. It's all about identification of projects of similar nature and putting them in a box, in a compartment. And last but not least, the classic variance analysis. This is called the waterfall chart. It shows you an initial stance, it shows you a final stance, and what has changed with a positive or a negative sign between that initial stance and that final stance. So these could be some of them analytical techniques for how you could undertake the classic cost intelligence. One of them use cases that lots of companies pay a lot to have is having a QS like any of us, working for 6 to 9 months, and then flying through hundreds of bills of quantities, trying to export resources in terms of staff, in terms of materials, in terms of plant, and then understanding how much they cost, and then put them in a database, understanding the base date of this data, and using the building cost information service, which is devised by the RICS. They give you inflation indices, like the Office of National Statistics, but for construction. Once you have that resources database, you can then easily advise quantity surveyors, estimators, cost managers, and lots of other people about how much a thing could cost based on the historical data that we do possess. I'm going to show an example that I have built. So basically here, we have, for example, reinforcement concrete foundation, and you have different quantities from different data points, and then you would have the unit rate, okay? That's the base date unit rate based on the date here, which is the 1st of June. It could be 1st of June, 1st of July. And we have in the database inflation indices, which enable us to inflate from that date in 2023 to our desired date, which you can find here on the slides that are up top with that filter. So it is inflated up to October 2025, and that's the inflated unit. There's a reason for why I'm doing this. If you can see here, that's called a box plot or a box and width plot. It shows you the range from the lower bound to the upper bound with the average in here of all this data. Instead of just having 3 values, you have whole spectrum. And then what I say to any quantity surveyor, you have the whole spectrum, do your own judgments, research, and choose a value in between. Time intelligence mainly is for planners. It's all about understanding the program, the delays that happen, productivity differences, understanding why this happened in the past or what happened first and why it did happen, and then trying to, as you might have heard in the news, flatten the peaks and troughs so that you don't have a month with a substantial amount of productivity and then the next month no one's working on site. So flatten the utilization of resources. That's all about time intelligence, identifying delays, identifying differences between programs, and then trying to use mathematics, simple mathematics, to flatten the usage of resources. So the traditional approach, again, is sort of, we're now reaching a level where the science is not changing. The science is not changing in any way, shape, form. The scientific contributions over the last potentially 30, 40 years are not massive, but the change in tools is massive. And that is quite important. Unfortunately, all of us in the construction industry will have to follow the latest advancement in the tools provided. Building a Primavera P6 schedule didn't change in any way, shape, or form. You will have a work breakdown structure, the activities based on your understanding of construction, and then finger in their approach for the durations, but the tools, they have changed. Nowadays, for example, there is a company called N-Plan. N-Plan, they have trained their own machine learning model and large language model on quite close to 750,000 schedules or programs, and that enables them to provide you with a more educated guess on the potential work breakdown structure of a project and also the durations of the activities. As you can see on the screen, it's a very, very minimal example, understanding what changed between January 2025, February 2025 in terms of one of them work packages. And you will see on that table that the duration decreased by a couple of years. So that resonates with what we have just discussed. It's all about building a historical database, trying to train a model, not necessarily a very sophisticated model, even an old machine learning model from 15, 20 years ago. The same algorithms, they work. And then you could predict what's going to happen in the future with definitely some degree of confidence, and then apply to the projects at hand. The risk intelligence, well, the risk is always about what's going to happen in the future. So the cost and time analysis or intelligence, it could be for stuff that are happening now. You're doing the floor finishes here. Okay, so that is not going to be done in the future. It's being done right now. The risk is sort of something that is unknown. So you have the known knowns and unknown unknowns. I know it's a bit of a jargon, but it's basically the stuff that you can anticipate is risk. The stuff that you cannot anticipate is contingency. Nowadays, normally the majority of quantity surveyors like ourselves, we head towards the qualitative risk assessment. We are working on sites, there's quite a lot of groundwater, so the groundwater is going to be a risk, and that risk is high, medium, low. That's the linguistic terms. We should be quantifying this based on previous projects, understanding how much a water-related risk costs in previous projects and what is the probability of having the same risk within the surrounding area. That enables us to have some sort of like a quantitative risk assessment and give figures. It's all about numbers. So the risk analysis definitely is going to be quite important for all of the teams. If you're a client, you'll have to understand how much you're going to be setting aside if risks materialize. And for commercial teams, that is going to enable us to advise the clients on how much they have to keep aside, especially when you are building a cost plan. Because sometimes what really happens is you say that based on the same projects, we're going to be setting aside 10% as a risk analysis, which is not a great approach. Have to quantify the risks and potentially advise on how much should be set aside in terms of figures. The common applications, well, there's a fair bit of applications. If you're a client and you want to go or you want to take a decision whether you want to invest in the Royal Docks area, should I invest in building a high-rise apartment block or a resi building, a residential building, or not. So having a quantitative risk assessment, it's going to enable you to take the bid, no bid decision. I'm pretty certain some of you might have watched Oppenheimer movie. I'm giving that example. Why? Because the Monte Carlo simulation is better known as the Manhattan Project. So the Manhattan Project was the when the US they did what they did to Japan in the Second World War. That is the Manhattan Project. Why I'm saying this? Because the Monte Carlo simulation was devised in this era. For something to happen, for example, if I'm going to walk there, this does not have 1% or 1 probability of occurrence. It's sort of like a bell-shaped curve, a normal distribution. So what is the probability that tomorrow is going to be raining? It's never going to be 50%. It's following a normal distribution between 25 to 75%. So you have a normal distribution. When you look for hundreds or maybe thousands of risks in a project, you will begin to think in a way that is much more sophisticated. Each and every single risk event I have normal distribution, not just one number. 50% I'm going to have the washing problem. No, it's normal distribution between 30% and 80%, and it's any number in the middle in that bell-shaped curve. So when you look at that, you can have millions of scenarios in one project, and that's going to enable the project teams to understand which scenario has X degree of confidence in happening. That's what I meant by Monte Carlo simulation, having millions of scenarios for bell-shaped curve across a multitude of risk events. That resonates with what we have just said. The probability distribution is not just 50% we're going to have a problem with the water, 35% we're going to have a problem with the finance. No, it's bell-shaped curve. The problem is in the data collection. The risk impact on overall projects, you will have to think of risks in isolation and also as sort of collective set events. And last but not least, it's confidence. It's not just one figure, but rather confidence. I can advise with 85% confidence that something is going to happen. I cannot say for certain it's going to happen. So the third act is the hype, ChatGPT. But what can this actually do? I'm going to tell you a very interesting story of one of the professors, one of the unis, like Sylvester. She was drafting a bit of paper, sort of like an article or research, and then she was asking ChatGPT to help her. She's saying the $200 a month subscription program, not the classic $20. So she was asking ChatGPT to help her with the findings, the critique, and also the list of preferences. And the problem is, she was trusting ChatGPT. It provides list of preferences in a way that is quite convincing. It provides the pages of books. It provides the names of the books. And that is alarming. Why? She put that for peer review. Fortunately, she has got a person who is what's it in review, and he told her what you're doing is a lot of BS. Why? She trusted ChatGPT. He gave her the names of the books, the paragraph from where the facts or so-called facts were extracted, the page number, the name of the author, and the name of the the reviewer and the like. Apparently, that was all a lot. So that is a huge problem. What is the moral of this story? ChatGPT, Gemini, they are really good in identifying patterns. They cannot advise you using closed source information. So they don't have access to Wiley. You know Wiley? Wiley is that huge publication house or references that we all have used in universities. They don't have access to Wiley. Wiley is closed source. They don't have access to Elsevier. Elsevier is behind a paywall. What it can do currently, or at the time being, is summarizing. So I myself, I supervise quite a lot of quantity surveyors when they're doing the assessment of professional review for the RSS. And what I tell them is activate the voice recognition within chat, speak with it, and let it summarize or restructure what you are saying into proper English. Sort of like grammar. Sometimes you can ask it for stuff that you don't know to teach you, but then you have to search. You have to do your own due diligence. It's really good in document analysis. It's fairly decent in image recognition. Predictive analytics, that is not LLMs. That is machine learning, and that has been available since the 90s, really before. Natural language processing, I'm not going to say it basically breaks down voice into small bits and pieces. It puts it through some people an embedding model, and then it's classic GCSE's mathematics, matrix simplification, giving you the probability that the red fox jumps over the fence. So it gives you the probability that the red comes to the fox, and then it gives you the highest probability of that word. Spits that out to you. It doesn't do inner reasoning. Even the reasoning models, when you are having a subscription with Anthropic, with Claude, whoever it is, it doesn't reason. It has something called chain of thoughts based on how it's literally following instructions through chain of thoughts behind the scene. The emerging technologies, the classic stuff that you would see online, having a chatbot service, what's called service centers. When you're calling customer service, potential 5 years from now, they keep saying robotics, and they keep saying humanoids, we're going to be replaced by AI. You have to keep people, as they call it, human in the loop. Autonomous site monitoring, I think that's the only thing that is really useful. Autonomous site monitoring and fraud detection. So image recognition. Because, for example, I'm working in the stations at H2 and I receive on a monthly basis quite close to 1,000 invoices for one station, PDFs, sometimes scanned PDFs, which means image. So I'm not going to be looking at converting 1,000 images into a classic table to analyze. I need something that does this quickly. So I think drawings and fraud detection, which is basically image recognition. So we have said that AI is good in some stuff, not so good in other stuff. So how can we use it properly? I would say it has access to countless bills of quantities. So it can help you when you are drafting the bill of quantities, just the wording, not the actual bill of quantities. It can help you also with the specifications, because the specifications is open source. You can find British Specifications Institute, which is the BSI, as substantial amount of PDFs that are available to download. How would you ensure that it is following the British standards? You can download this data online. So the LLMs, they have access to this meeting minutes. Probably that's the best thing. You can record your professor, then you can use Copilot or any of the other models to summarize what is happening. Prompt responses, the classic use that I'm pretty certain you use it for that. And also learning, if you want to learn more about contracts, also you have to do some sort of trial and error to understand what is the data that's going to be always closed source, kind of paywall, and what data could be available to the public. I would say the data that you have access to is potentially the same data that the LLM has. And last but not least, it can help you massively when coding. So you can use it to learn how to code, and it can guide you bit by bit. That ties in with what we have just alluded to, that hallucinations, it spits out fallacies. From my own perspective, and that's one of the use cases I'm going to show you in the next slide, is some people fine tuning. So you can fine tune open source large language models or domain specific data. We would like this stuff to be somehow relevant to what we want, or what we work with. Because, for example, if you're working in a sensitive project, ChatGPT or OpenAI models will never have access to that. So I'm going to give an example. I'm a huge advocate of getting chartered with RICS. You're year 3, potentially going to get chartered or sit for your assessment within the next 3 to 4 years. You have 1 year remaining. You need 2 more years with the RICS. So potentially going to be sat for the assessment within the next couple of years. So what I was trying to do, I've done it a lot. I've created lots of videos about it. Basically, I collated a substantial amount of RICS APC submissions, and then I extracted from it the perfect answers for the different areas of competencies. Give me a good quality example for procurement and tendering level 1, 2, and 3, and whoever it is. Questions and answers. That's the keyword. Questions and answers pairs. And then, without digging deeper into the code itself, it's basically fine-tuning some of them parameters of the large language model of choice. And then once you finish the fine tuning, and again, this is all free of charge. So you can use a front end. This front end, FYI, it's called Open What You Want. Free of charge, open source. You can download it from upload the model that you fine tuned, ask it a question. ChatGPT can answer how much does it cost me? 0. Just my laptop. You can have, I would say, 600-700 quid laptop that does this stuff for you without using ChatGPT, and it's going to be much more accurate than ChatGPT. Why? Again, closed source information. RICS, it keeps the documentation for the candidates not behind the paywall, it doesn't share it. So ChatGPT, Claude, Gemini, all of these LLMs, they will always spit out fallacies. It's never going to be true. You are the future of this country, and you are the future of this career. You're going to be the new generation, QSs. The traditional skills that they teach you in uni is the classic stuff that we have been learning for the last God knows many years. How to quantify, how to price, how to view the contracts. What does the contract clause X mean? That is good and all. I'm not saying that is obsolete. That is still good. That is still relevant. But you will have to exert a substantial amount of efforts in the data literacy. I'm not saying be software engineers, but learn a little bit how to use these LLMs to teach you, and bit by bit. There's a website called Kaggle.com. Kaggle is quite good because it provides a plethora of datasets in different formats. CSV, Excel, you can use all of that to train. So use some of your time to train in this build the momentum over time. So it's all about the stuff that you learn here in uni, plus training on data analytics. I'm not saying you have to be an AI engineer. You're not going to be applying to work in Apple. That's good and all, but you don't need to reach that level to gain this kind of digital skills. So that ties up with what we have just said. Data visualization is a huge topic nowadays. Even in Atkins, we were just having quite a lot of advertisements with those people working in project control with a data analytics background. Basically, a QS with some data analytics background, a person who knows how to deal with complex Excel, a person who can deal with huge amounts of data, mapping the data, manipulating the data, a person who can code a little bit. We're not hiring software engineers. It's not software engineering per se. Just know how to code a little bit. So the journey map, again, that is my piece of advice. Start with Excel, the classic Excel. You can use Kaggle to deal with a substantial amount of rows of data. Power Query is it's an engine inside of Microsoft Excel and inside of Power BI. It allows the end user to ingest data sets of different formats from Excel, from databases, wherever it is, and then you can do all the manipulation. Power Pivot, it is used within Excel to summarize. For example, if you have a substantial amount of data that is happening in January, February, March, so on and so forth. If you have like 10,000 rows of data for costs that happen in 12 months, you can summarize it using Power Pivot so that you have only 12 lines. It's sort of like sum if. It can provide you with sum if, average if, count if, sort of like the if statements in Excel. Power BI is the cherry on top. It's a piece of software that allows you to visualize, have fancy graphs than Microsoft Excel. So the one in Magenta is called House, low code platform. If you can code using Python or any language, you can skip the one in blue and the one in Magenta. So the one in blue is called Automate. It allows you to make it flows once they are triggered. For example, you can send an automatic email to any of your professors once they have sent you an email containing the word assignment. It can do quite a lot of stuff, but it's basically a workflow builder based on a trigger that works. And then last but not least, programming language. So the main two programming languages you utilize widely nowadays for this kind. It's Python and R. Python, it's sort of like the ocean. You can swim here, you can swim there, you can swim everywhere. So it can help you to analyze data, it can help you to build websites, it can help you to develop an application. So these are the main things in Python that's going to help you as well as to be ahead of the game. Pandas and NumPy is so the classic matrix, multiplication, and addition. There are some deprecating techniques in Python using these two libraries. So it's for machine learning algorithms. And then definitely you will find online nowadays quite a lot of videos on YouTube free of charge that shows you how you can deploy ready-made open source LLMs to do, for example, sentiment analysis or summarization, as we do with Amazon. You can create your own chatbot at home. What we have covered so far is all about understanding the requirements of your clients and your company, understanding what data needs to be collected and collect it, and I would say put some parameters to make it standardized. And then you can apply the classic stuff that we have spoken about, the cost, time, and risk intelligence, and be quite careful with anything that has the word AI. Identify what key areas require AI per se to be implemented. I would say use the current large language models to facilitate the delivery process. And it's all about feedback. So yeah, learn from your mistakes and move on. Honestly, that's one of my frustrations in our industry. Not a lot of people have a personal computer, which is weird because when you're working at any company, you're always going to be engaged with what the company is going to provide in terms of applications, coding, tools, and the likes. So I would say investing in your own laptop, investing in courses that you can attend, is definitely going to pay off. I can easily say that I'm 10 times faster than my peers at work. Not because I'm better than them, but because I have the tools that do the mundane tasks for me. What's going to be happening in the near future and the relatively far future? I'm not sure whether AI is going to materialize into something really useful or not in the workplace, especially in the construction. but I can say that it can help with automation of mundane tasks, like what we have said concerning answering questions, fraud detection, image detection, and the likes. You would hear in the news that there's something called agentic AI. So having an agent that studies what you are feeding into it, and then it can follow your lead. So I think when you graduate, potentially you're not gonna be a classic QS. You're gonna be an orchestrator of agents. But in order to orchestrate all of them agents, you will have to use your quantity surveying knowledge from university and build on it so that you can orchestrate and have a team of agents. You are going to be managing teams of agents rather than actual people. And if you're reaching this point, I really thank you for watching the video on the lecture, and I hope that you have found it useful and insightful. You will be able to find a link to the presentation that was discussed in the lecture in one of them links that I'm going to be putting in the video description box below. And if you really liked what I've seen so far, do not forget to give the channel a thumbs up, and do not forget to hit on the bell icon so that you can get notified of new videos when issued. Thanks a lot, folks, and catch you in the next one.